Hi guys. In this video, we are going to do double and half argument properties. Sometimes you will hear these referred to as double and half angle identities. Um, you're going to hear me kind of interchange those a lot. When I went through school, we called them the double and half angle identities. In our textbook, it specifically says argument properties. And so I just want you to know that those are interchangeable, double and half angle identities. So that's what we're going to talk about. We're actually going to talk about a whole lot of these different identities. You're going to see kind of this string of stuff on the side of this whiteboard. Um, and the first thing I want to say is don't get overwhelmed. You do not have to memorize any of these. You will be given a full document with all of the different trig identities that we'll be using to transform, and that will be given to you. The ones that you want to have memorized are the Pythagorean properties, the quotient properties, the reciprocal properties, but these ones you just have to know how to use them. Okay, so the first set of properties that we're going to look at here, they're just kind of cool to know. When you multiply sine and cosine together, it is exactly the same thing as 1/2 sine 2 of x. That's kind of cool. You can check if what I'm saying is true by going to Desmos. Desmos was supposed to pop up and it didn't. So you can check if what I'm saying is true by going to Desmos and actually just popping in here sine of x times cosine of x. And then we said, well, this is equivalent to 1/2 of sine 2x. And look at that. Those graphs lay right on top of each other. And so what that tells us is that these are equivalent, meaning that you could interchange sine of x times cosine of x for 1/2 sine of 2x if that made your life easier. If you didn't know what cosine was, but you knew what sine was, that might make your life a little bit easier. And we could actually check this for all three of them that were in that list. The next one was cosine squared of x. And the property says that that's the same thing as 1/2 plus 1/2 cosine of 2x. And sure enough, if you look, these two graphs lay directly on top of each other. And so they are exactly the same thing. So you could interchange these things. You could also rearrange because you're setting those equal to each other. So you could rearrange them and get something else, which is pretty cool. And then the last one is sine squared of x, and it's the same thing as 1/2 minus 1/2 cosine 2 of x. So those are pretty cool, just little properties to know. Alrighty. That's as much as we're going to work with those. I just want you to know that they exist. That's it. All right, so now we are going to move on to double angle properties. And so again, don't worry about having these memorized. What I really want you to know is how to use them. So if you're given something like sine of 2a, that's exactly the same thing as 2 sine of a cosine of a. Mrs. Roberts, why the heck would I need to know that? Well, every time we drew those reference angles, we were able to figure out sine, cosine, tangent, secant, cosecant, cotangent. We didn't know what sine of 2a was, but we could find sine and cosine. And so that's why this is easier. Cosine is unique. Cosine of 2a has 3 different properties you can use. You can use any one of these properties and you're going to get exactly the same answer. And so my advice to you is pick the one that seems easiest to you. And then the double argument property of tangent is 2 times tangent of a minus 1 over tangent squared of a. One thing that you'll notice is that in all of these, there is no longer a 2 inside of your argument, and you only have sines, cosines, and tangents. So that does make life a little bit easier. Okay, let's do a practice. And the practice I'm going to give you is going to be similar to what you might see on a test or your final. And it's going to put together quite a few different things. So in this practice, let's say we know that secant of x is 13 over 5. And we also know that secant of x is between, I almost wrote a theta. We know that x is between 3 pi over 2 and 2 pi. And what we're going to do is we're going to find the exact, I'm going to write that really big, values of, let's do sine of 2x. Let's do cosine of 2x, and let's do tangent of 2x. So we're going to find the exact values of all three of them just for good practice. And so what we're saying is take this angle here and double it. So we're going to take the angle that's here and we're going to double it. And you know what? You could actually figure out what this angle is by doing the inverse secant or the inverse cosine if you flip this. So just like in class, my advice to you is always draw first. And so let's go ahead and just type that on here. We'll say Mrs. Roberts' advice, and we can add to this document as we go. Draw the triangle first. Okay, so we're going to draw our triangle first. That's my first piece of advice for you, and we will add to this as we go. So let's go ahead. I'll use this sweet rainbow pen, and we will draw this triangle. So it tells us that the triangle is going to be between 3 pi over 2, and 3 pi over 2 is pointing straight down, and 2 pi. So our triangle has to be in this quadrant. Now, at first, that might not seem like it matters very much. Your triangle is always drawn up to the horizontal axis, and the reference angle is between your terminal ray and that horizontal axis. So, secant is the reciprocal of cosine, and cosine is opposite over hypotenuse. So that means this must be hypotenuse over, did I say opposite? I meant to say adjacent. Adjacent. So hypotenuse over adjacent, because cosine's adjacent over hypotenuse. So the importance of drawing out the triangle first is to make sure that you don't miss any signs. And that's important. You don't want to miss any signs. Missing signs, ooh, what did I do? I don't know what, I'm making it really small and I don't want it to be small. Oh well. You don't want to miss any negative signs. And so here, when we solve this out, and you can solve it out using the Pythagorean theorem, a squared plus b squared equals c squared. And so we have 5 squared plus something squared equals 13 squared. And so we'd have 13 squared minus 5 squared equals b squared, which is 169 minus 25 equals b squared, which is 144 equals b squared. B is 12. Now we don't want to miss any signs. Because of the quadrant that this is in, this is negative 12. So draw out your triangle first, and then make sure you don't miss any of your signs. Now, we're trying to figure out what is sine of double this angle, what is cosine of double this angle, and what's tangent of double this angle, right? That's what we want to know. You could figure out what this angle is. Let's not do it until the end. I don't want to blow any surprises, but I will. I'll go through and I'll show you guys some really cool tricks on how to cheat the system on finding the right answers here. The next thing is determine what sine, cosine, and tangent of the angle are. So we want to find sine, cosine, and tangent of this angle. And you can do that using this triangle. Here's the angle. Here's opposite. Look at this. This is opposite. This is adjacent. And this is hypotenuse. So our sine of theta is negative 12 over 13. Our cosine of theta is 5 over 13. And our tangent of theta, I guess all those should be x's, is negative 12 over 5. Okay, so we have figured out what sine, cosine, and tangent are. Now we're ready for the precalculus piece of this. Sine of 2x. We're going to go over here to this double angle property. Sine of 2x is the same thing as 2 sine of x cosine of x. A. Sine of 2x is exactly the same thing as, let's do that in white, 2 sine of x cosine of x. Right there. There we have it. We know what sine of x is. It's negative 12 over 13. We can replace this entire sine of x with negative 12 over 13. We know what cosine of x is. It's negative 5 over 13. We can replace that. That's just numbers. That's just numbers. Oh, that's not negative. I accidentally erased part of it. Good thing I noticed that before we got too far. That's just numbers. We know how to multiply because we're really, really smart. So all of these are in our numerator, so we'll multiply straight across. 2 times negative 12 times 5 is going to be negative 120. 13 times 13 is 169. There we go. Sine of our double angle is negative 120 over 169. Pretty freaking cool. So the pre-calculus piece of it was just plugging in what we knew, and then it was algebra from there. All right, let's try cosine of 2x. Let's try cosine of 2x. I don't think that we need this piece anymore, so I'm going to erase my beautiful rainbow pen and make some room so I can try to keep most stuff on one piece of paper here. So we're going to do cosine of 2x. Now, cosine's unique. We have 3 different options here. If you pick the first one, you're going to get exactly the same answers if you pick the second one as if you pick the third one. It doesn't matter which one you pick, you're going to get exactly the same answer. Let's go ahead and just pick the first one. And what the first one says is that if we take cosine of x and we square it, and then we subtract sine of x and we square it, we're going to get whatever that double angle is. Well, we know cosine is 15 or 5 over 13. 5 over 13. Just replace that. Don't forget to square it. We know sine is negative 12 over 13. Don't forget to square it. We did the pre-calculus piece of it. Now it's just algebra. 5 squared is 25. 13 squared is 169. Negative 12 squared is 144. 13 squared is 169. 25 minus 114 is negative 119. 169. That is the double angle of cosine. That's our double. So if we were to take this angle here, and double it, double this angle, we are going to get the value negative 119 over 169. Now I'm going to challenge you. I want you to pause this video and I want you to work out cosine 2a using this formula and cosine 2a using this formula. Pause the video, work it out with the 2 other types, and see what you get. So make sure to pause the video. Pause. That's a pause sign. Okay. I'm hoping that you paused the video, that you worked that out, and you saw that you got exactly the same thing. Pretty cool. All right, so now we're going to do C, which is finding the double angle of tangent. So the double angle of tangent, what we need is 2 times tangent of x over 1 minus tangent of x squared. So what we need to do is replace the tangent of x with what we know, which is negative 12 over 5. So negative 12 over 5. So we're going to have 2 times negative 12 over 5, 1 minus negative 12 over 5 squared. We're going to do some algebra here. So in our numerator, 2 times negative 12 is negative 24 over 5. In our denominator, we're going to have 1 minus 144 over 25. We need to combine this, so I'm going to change this into a 25 over 25. I'm going to move this for a moment. Oops. Scroll that up, move that. Okay, and so this becomes negative 24 over 5 over negative 119 over 25. We have this really ugly complex fraction, and we can rewrite that ugly complex fraction like this, divided by, and then you cross multiply. And then you can simplify, and so this becomes negative 24, and this could simplify into negative 24 times 5 over negative 119, and negative 24 times 5 is 120. And there we have it, that the tangent of the double angle that we started with here is going to be 120 over 119. Now, the pre-calculus piece of it is this right here. That is the pre-calculus piece of it. If you are freaking out about the rest of it, you're like, oh my God, a lot of math just happened and you went way too fast for me. Good thing this is a video and you can hit pause, right? The other really good thing is that you can just take Desmos and you can type that in. You can type that in exactly. And so we had 2 times our tangent was negative 12 over 5 divided by 1 minus our tangent squared, which was negative 12 over 5 squared. And look, it gives you this answer here, 1.00840. But Mrs. Roberts, you said that it had to be exact, and that's not exact. You're right. Click this fraction button, 120 over 119. So if you are super concerned about doing the algebra piece of it, just use Desmos or your graphing calculator and convert it back into a fraction. So there we go. All right, we have one more topic to talk about here, and that is half arguments. So again, don't freak out. Yeah, this is this is a lot of information. This is a lot of formulas, but you will be given a sheet with all of these formulas. You do not have to have these memorized. So half argument properties, before I get too far, let's go ahead and I'm going to drag my advice down to make sure that we always have it kind of in front of us. Half argument properties. They look a little bit ugly. They're not as bad as you think. So the way that you tell half argument versus double argument apart is it has a 1/2, whereas the double has a 2. So you just need to be able to recognize, oh, this is what it's asking for. I apply this formula. Oh, this is what it's asking for. I apply this formula. So sine only has one option, cosine only has one option, tangent has three. And just like the tangent before, or the cosine before, you can pick whatever one is easier to you at the time. So we have sine of the half argument is going to be plus or minus the square root of 1/2, 1 minus cosine of A. This plus or minus is a little bit different than before. This plus or minus, oh no, where'd my pen go? This plus or minus is actually ambiguous. You have to pick which one it's going to be. And let me tell you how you'll pick. So how you will pick is pick the plus or minus dependent on what quadrant the half angle sides lives. So you have to figure out where is that half angle going to be, and after you figure that out, what would cosine or sine or tangent normally be in that quadrant? So again, my advice is going to be draw the triangle first. Because by drawing the triangle, you can then analyze, okay, if I were to cut this angle in half, it's going to be here. So let's do an example. Um, let's say cosine of A is 15 over 17. And this lives between 270 degrees and 360 degrees. Okay, and we're going to do two things. We're going to find a half angle, and then we're going to take it back, and we're going to find a double angle, just for fun. So my advice is always going to be draw this triangle out first. So 270 and 360 is the same quadrant we just did. So it's going to be here. Draw it up to the horizon, and there's theta. Cosine is adjacent over hypotenuse, so we have 15 and 17. And then if we were doing Pythagorean theorem, we could do 15 squared plus b squared equals 17 squared. 17 squared minus 15 squared equals b squared. 64 equals b squared. B equals 8. Because of the quadrant that we're in, this is going to be negative 8. I don't know what just happened to my pen. Negative 8. So, drew the triangle, made sure not to forget any of our signs. Okay, so this angle resides here in this quadrant. If I were to cut this angle in half, where do you think the angle would be? Well, we have a really good technique for finding what that actual angle is. And when you find what the actual angle is, we can actually go back and we can check all of our work. And we could go back and do that for the first problem as well. So that angle is going to be the inverse cosine of 15 over 17. That's going to be the actual angle. Now remember, the inverse cosine is always going to give you the angle in this quadrant here. So you would need to figure out, how do I find the angle that's in this quadrant here? So using reflection, we would take the angle we get here, and to reflect it over this line, you would do 360 minus that angle. So let's see. Let's see what we get here. We're going to do the inverse cosine of 15 over 17. Oops. I don't know what button I clicked, but it was not the right one. And we get 28 degrees. Well, 360 minus 28 tells us that our angle is actually 332, because 332 falls in this quadrant. 332 falls in this quadrant And 28 does not. 28 falls in this quadrant. And remember, cosine reflects this way. Now, to figure out where the half angle resides, divide that by 2, 166. 166 is going to be up in this quadrant here. 166 is in this quadrant here. Well, cosines are negative, sines are positive here. And so, when we are finding this half angle, we're going to use the negative portion of this radicand. So, half angle, we're going to have negative square root 1/2 1 plus, what is cosine of A? It's 15 over 17. We'll just replace the cosine of A with 15 over 17 because we know what that equals. Now we have to do some algebra here. Well, I'm going to change this 1 to be a 17 over 17. And when I do that, I get negative square root 1/2 of 32 over 17. And 1/2 of 32 over 17, well, 1/2 of 32 over 17, that should be 16 over 17. And we're almost there. This was the pre-calc piece of it. The rest of this is algebra. The rest of this is simplifying. So if I were to break this down, I would get the square root of 16 over the square root of 17, which is negative 4 over root 17, rationalize. And my final answer is negative 4 root 17 over 17. Now, what we just did was we figured out that we were going to use the negative piece of this. And we knew we were going to use the negative piece of this because we had to figure out what quadrant this was in, the half angle. Now, we have a pretty good idea what that half angle is. We could put in that angle here and see if it's pretty similar to the answer that we got. So, we were finding cosine of, and we wanted to do the half angle of, let's make it a little bit more exact here. The more exact we are, the better. So the half angle of 331.9275131, we get negative 0.97. Now let's see how close that is to our answer of negative 4 times the square root of 17 over 17. And that looks pretty dang accurate to me. You do not have to do this last piece. This last piece is just something that really helps me figure out, did I do this question correctly? Alrighty, so let's finish this example. So we have cosine of 2a next. And in order to solve that, I have to go back up here and grab my double angle identities. Like I said, you don't have to have it memorized, so it's totally fine if you are looking at what that identity is. So cosine of 2a, I have 3 different options to choose from. Now, if you hadn't drawn out the triangle, you could use that middle option because you wouldn't need to know what sine of theta was. So let's go ahead and do it that way. Let's say, okay, I want to find cosine 2a. And so I'm going to have 2 times cosine squared of a minus 1. Well, I can replace that cosine squared with 15 over 17. I need to actually square that out. And again, if you are like, oh my gosh, the algebra part of this is going to kill me. Well, you have all of the pre-calc there. Plug it in. 2 times 15 over 17. I don't know why I keep putting a question mark. Squared minus 1. Change it to a fraction. And you get 161 over 289. And you didn't have to do any of that algebra because Desmos did it for you. So this is 161 over 289. Now, just for fun, if you want to check yourself, again, you don't have to. If you want to check yourself, does that seem right? Go back to Desmos, and you want to do cosine 2 times the angle that we got as close as we could get it was 331.9275131. Okay, and then 161 divided by 289, that is pretty dang close. That's pretty dang close. And so that's just a really good way to check your work.